This next example comes out of section 6.1, reciprocal quotient and Pythagorean identity. In this example, we're given a verify numerically question. We're given an identity that is on your formula sheet. It's one of your Pythagorean identities, and it says 1 plus tan squared equals secant squared. And we're verifying it numerically, specifically for theta equals pi over 6. If we're going to do this with exact values, I might want to remind myself what pi over 6 is and what the coordinates are on the unit circle. So that means that I know that cosine of pi over 6 is root 3 over 2, and sine pi over 6 is 1 over 2. If I'm going to verify numerically, I like to set up my left side and right side table. I put the left side of the equation here. I put the left side of the equation over here. And now I'm going to substitute in specifically pi over 6. So I've got 1 plus tan squared pi over 6. And on the right side, I'm going to have secant squared of pi over 6. So, what is tan? I know that tan is sine over cos. So I've got sine pi over 6 divided by cos pi over 6. And all of that will be squared. So I've got a half divided by root 3 over 2, all being squared. You might simplify the fraction in the middle first and say, well, 1/2 times 2 over root 3, and then square it. So I've got 1 over root 3 squared, which is 1/3. So on the left side I have 1 plus 1/3, or 4/3 as the final answer. Now on the right side it's a little simpler. Secant is just 1 over cosine, and I have to square that answer. So since cosine was root 3 over 2, secant is going to be 2 over root 3, and I'm going to have to square that. If you square the top, you get 4. If you square the bottom, you get 3. And you do get the left side equal to the right side. So it's not a proof, not quite as powerful as a proof, because really all I've shown is that for this one particular number, theta equals pi over 6, this equation holds true. But it is definitely a skill that you're going to need to have as you go on through 6.1 and into the later parts of this chapter. And so also the fact that we have to practice using so many exact values in unit circle numbers, practiced a few of the previous things in trigonometry as well.